Hey everyone, Mr. Fransky here again. It's kind of the third part of our series here about how to use the calculator for calculus. First of all, we have our document all set up. If you need to go back and watch the video about how to set up a document, please do that. But we're going to go and open in my documents, the calculus document. I have it down here, so yours might automatically go to the bottom, or you might have to scroll down. So I'm going to open up my document. Now I know all my settings are going to be right. I'll be in radian mode, and I'll be on float. Those are the two big things, remember. So today we're going to talk about some graphing tools. We've noticed is that because we kind of take the year in pre-calc to focus on algebra skills, we don't do a lot of graphing with the calculator. In fact, we don't do any at all. And this is stuff you may have seen in advanced algebra, but you may not have seen in a while, and so we just want to go over just some things about how to change the window on a graph. We're going to talk about how to use some of the zoom tools that are some of my favorite things on the graph, how to solve an equation by graphing, and also we're going to talk about graphing parametric and polar functions on the calculator, since those often come up on the AP test, and it's nice if you can get a picture of what's going on. A big thing to remember here is that it's not like the AP, like College Board, which writes the AP tests, just keeps writing the same problems as technology develops. They're writing problems that are designed to see if you know how to use your calculator effectively, not if you just know, like how to use the solve function. So we're going to take a look at some of these ways to graph, to solve some equations, and to do different things, and hopefully you'll learn something today. So I have my calculus document open, and I'm going to open up a calculator. I'm also going to open up a graph. So go back to on and add a graph. You can use your arrow keys, remember. And so now I've got a regular calculator window and also a graph. We're going to be using both of those today, and probably add some more. So first of all, we're going to talk about changing the window. So I tell you, some functions are not as they appear. This is actually a function that was given on the AP test shortly after the Inspire became available. So let's graph it and let's see what happens. So in my graphing window, I'm just going to graph 20 divided by parentheses 1 plus x squared. Now think about why I need those parentheses. I need them because that 1 plus x squared is all in the denominator. If I don't do that, then it's only going to be 20 over 1, and then it's going to be plus x squared to make a parabola. Now when I graph that, take a look at this. And I asked some very specific questions about this. What's the domain, and does it have zeros? So I think sometimes we just blindly throw a function into our calculator without really thinking about it. This is a great example. So when I look at this, to be honest, if I looked at this, what does it look like the domain of this function is, just by looking at the graph? So if we look at the graph, it looks like we're okay to the left. It looks like we have a horizontal asymptote at y equals 0. To the right, looks like it's the same. But as it comes closer to 0, it looks like 0 might not be in the domain, right? It looks like we might have a vertical asymptote at 0. But this is where I really encourage you to look at the equation, right? Look at the equation here. So two things I want to say. So one, yes, we do have a horizontal asymptote at 0 because we have a bigger degree on the bottom than the top. So as x goes to positive or negative infinity, our fraction is going to turn into 0. But look at 0. So our hypothesis was that 0 is not in the domain. Is 0 an issue, though? If you plug 0 in there for x, is it a problem? We would have 20 divided by 1. No, that's 20. That's not a problem at all. In fact, x squared is always a positive number. If you take a positive number and add it to 1, it will never be 0. So the domain of this function, the domain here, is all real numbers. And it will not have any zeros, because the only way you can have a 0 of a fraction is if the numerator is 0. So that won't happen at all. So the thing to do here is, well, I need to see higher on this graph to be able to see what's going on up there. Because if it's not an asymptote, we want to see what's going on. And this is exactly what AP wanted. They wanted people to look at this and say, oh, it's an asymptote. But it's not, right? So what I'm going to do is I'm going to go to Menu. And I'm going to go to Window Zoom. We're going to be doing a lot of stuff in Window Zoom in this video. And just talk about a few different things. So I'm going to hit Window Settings. So we said at 0, the Y value was 20. So what I might do is just change the Y value to, like, I don't know, 25, the Y max. So X goes from negative 10 to 10. The Y is now going to go from negative 6 to 25. And now we get a much nicer picture. We can see that we do not have an asymptote there. It actually comes up. It's kind of like a bell curve, right? So some other things that you maybe have played around with before. Basically, I just want you to play around with these. All of these different things. There's lots of different ones that can be really useful. We can always zoom out. Zoom out asks for where you want the center. So wherever you click, that is where it's going to be the center of the screen after it's done zooming. So if I center it here, then it's going to move my whole graph kind of down and left, right? If I center at the origin, then it's going to put the origin in the middle. I'm quite zoomed out now, right? So I might zoom in. going to tell you right now, I don't use zoom out and zoom in a whole lot. Zoom out sometimes, but then I use a different tool after I get there. Okay, so the whole point of this is, you just cannot judge a graph immediately by looking at kind of what you're given in the standard window, right? Okay, so if I hit escape anytime, then it's going to get me out of this mode. It gives me back to my arrow. I think that for you guys, it's a little different with me on the computer, but if you click and hold, I think that you're able to drag it around. You might have to double click, but some way there's a way to kind of drag your graph around. That's another great way to see what's going on. One thing I'm going to be using a lot today is Zoom Standard. So if I do menu 4, and then I go to 5, that's something that you might just be good to have on your memory, just menu 4, 5. For me, it's 4, 5. It might be different for you, but menu, and then I can just hit the 4 key over here, and then the 5 key, and that's going to give me Zoom Standard. That'll bring me back to the normal window for graphing. And I can still drag it around. I can see, oh, that's not actually an asymptote, right? Okay, so it's just an important way to see kind of what you can do. Again, to drag your graph around, you might have to double click the middle. It might give you that solid hand, and you can drag it around. All right, let's see what else we want to do. So Zoom Box. Zoom Box is like my favorite thing ever. I learned this on the old TI-83s, and I'm going to show you how it works on the Inspire. So we have this nasty function. Because we're going to be using it a little bit, I'm actually going to define this. Remember how we defined functions in our last video? So I'm going to go over to our calculator window. I'm going to do f of x. Remember where the colon equals is? I'm going to hit Control, and then that little funny button next to the 9 has that colon equals above it. And I'm going to type in this function. So we got 7x to the 4th. I'm going to cheat a little bit with my keyboard. Remember, you get out of that exponent, hit the right arrow. Minus 208.6 x cubed. You'll see why I have these very specific numbers in a second. Plus 2330.37 x squared. Of course, you guys can follow along if you'd like to here. Minus 11566.926x. Plus 21523.32. Okay, hit enter, and it's going to tell me it's done. Okay, we have that function now defined. And what they're asking for are the zeros. Okay, they're asking for the zeros of the function. Now, I know that a lot of you guys have a CAS. Okay, you have I think that I'm on a CAS right now. Yeah, it says right up here, I'm on a CX CAS. So the CAS, remember, is something that you can't use on the ACT, but you can use on the AP test. I'm going to try to get you guys away from using the solve function if you have a CAS, because a lot of you know you can just type in solve, and you can type in the function, and it'll give you the solutions. And I'm going to show you later why I don't like it. For this one, it'll actually work fine, but for the point I want to illustrate, I just want to graph this. So I'm going to go over to my graph. I'm actually going to hit tab. I'm going to get rid of this graph. So I hit tab and then hit the up arrow to go back to my old function. I'm going to delete that, and I'm just going to graph f of x, right? That's the one we just defined. Now what we have here is we have a polynomial. It's a quartic polynomial, so it makes sense that it comes down and then it goes up. And I'm asked to find the zeros. Well, right now, it looks like something funky is going on right there, but I can't really see what it is. We could use zoom in and try to zoom in on that exact point, but let me show you this. It is so cool. I'm going to go to Menu, Zoom, and I'm going to do Zoom Box. It's number 2 right here for me, so that was menu 4-2. If you want to think about that number combination, you can get to it really easily. And now it's going to ask for corners of a box. So what I'm going to do is I'm going to define a top left corner and a bottom right. You can also do top right, bottom left, or you can start from bottom to top, whatever you want. But what I want to do is basically just zoom in on this little piece. So I'm going to do a corner right there. I clicked. So I put it where I wanted the first corner, and then I clicked just the middle button right here. Now it asks for the second corner, so I'm going to just kind of, and I'm not holding, I just clicked once. Now I'm going to just touchpad down to the left here, and I'm going to click once again. And what it does is it zooms in on that exact box that I gave. Now I can see what's going on, but still not perfectly, so I might do it again. So I'm going to do a box from here to here. Now we can see really nice what those zeros are. Okay, and so now I'm going to go to Menu, Analyze, Graph, 0, and let's see what those zeros are. So click left to go through. Got our first 0 there, looks like 7.2. And notice the y was kind of buzzing around. That's because it's a really complicated function. That e-9 though means that decimal point moves 9 places to the left. So that's pretty much 0. Let's do it for the next one. Menu, Analyze, Graph, 0. Click across, there we go, 7.3. So notice all these are really tight together, which is why I wanted to do that different zoom. I wanted to zoom in on that, just that little box. 7.5. Also, when I move these around, I think once again, if you guys click and hold, if you click and hold, it'll latch on. It'll latch on, and you'll be able to drag it around. You might also have to double click it. I don't know exactly how it works with the actual mouse button. We got one more 0. Analyze graph 0 and drag it through, and now we have all 4 of our zeros. And it's a quartic, so it makes sense that there's 4 zeros. So zoom box, really nice way to get tight in on one spot, and you'll see me using that a lot. All right, so we found those zeros, no problem. Very cool. All right, find the solutions to sine e to the x, equals 0 on the interval 2 pi. Now, whenever you give it an interval, this is really interesting because there are a lot of ways to find those solutions. My favorite, once again, is graphing, especially because they want to support a sign analysis of the function on that interval. So I'm going to talk a little bit about the solve function now. So if you have a CAS, if you don't have a CAS, this can go in one ear and out the other, or you can fast forward the video, whatever you want to do. But the solve function, so most of the people that when they do this, they just type in solve. If you actually want to get to it, you go to menu, algebra, solve. Okay, so here's our solve function, and what I'm going to do is I'm going to type in the function. Let's do something easy first. Let's do like x minus 5 equals 0. So the equals key is underneath control here, equals 0. And you have to tell it what variable you want. Like if you had 3 variables in there, you might be solving for a specific variable. So you have to hit the comma button, which is next to the O, and then X. I'm going to go through this kind of fast because I think some people that use the solve function know how to use it. It's nice, but it's not something you have to know for AP. So we hit enter, and it says, okay, X equals 5, right? That's easy, right? If X equals 5, then X minus 5 is 0. Not a problem. Now I'm going to do it on this function. So I'm going to go up and grab it so I don't have to type in solve or go find it again. And it's already equal to 0, which I want. So I'm going to do, what is it? Sine e to the x. So e to the x, remember I have to use this thing over next to the 1. We saw that on an earlier video. Close the parentheses. Now, look at this. This is a mess. This happens a lot, and AP always has a sine or cosine function because they don't want people using the solve function. So what this n means, this is kind of like when we did like plus 2 pi n for our trig function solving. What this is saying is if you choose different n's, as long as n is positive and it's an integer, this will give you a solution to sine of e to the x. But the problem is I need ones that are on between 2 and pi. So I would have to try a bunch of numbers in here, find the values, and see if they work. That is not useful. Now, there is a way to do this. I'm going to show this once, and I still don't love it. I'll tell you why. So if I grab that equation again, what I'm going to do now is I'm going to get the vertical bar at. So I'm going to do control, and then I hit the equals sign right here, and it gives me some options. I want this vertical bar right here. That was control equals sign next to the 7. So I'm going to use my arrows or scroll over to get that vertical bar. And now I'm going to tell it where I want to find the answer. So I'm going to do 2, and go back to my less than or equal. So I'm going to do less than x less than pi. Or pi is next to the h. And now what it's going to do is it's only going to find solutions in there. And there they are. Okay. Now there are a bunch of solutions. I still don't love this format, but these are all exact solutions. If I do control enter, I think it'll give me decimals. Yep. So if I do control enter, it'll give me decimals. And these are, it looks like there's 4 answers, but I still have to scroll through them. And I also, the big thing here, I can't see any sign changes. Sign changes are really, really important. SIGN. Sign changes are really important when we do sign analysis in calculus. And you can't see it at all. You'd still have to make your own number line and find your analysis. So I just think graphing so much better for this. Let's take a look. So if I go over to our graph, I'm going to get rid of this one because I don't want it anymore. And I'm going to graph sine e to the x. I know I'm in radians because we set it that way. So we have sine e to the x, hit enter. And now I'm in a really weird window, so I'm going to go back to zoom standard. So I'm going to go menu, zoom, standard. There we go. Now look at this function. It is a mess. So I know 2 is right here. Pi is over here somewhere, but I can't really see what's going on. Now, you might say, well, didn't we just learn zoom box? Couldn't I just zoom in on that box? Yes, but there's actually a better way to do it. What I'm going to do is I want it, if they give you an interval like this, what I'm going to do is I'm actually going to set that as my x value. So I'm going to go to menu. I'm going to go to window zoom, window settings. So just number 1. And remember, this is the standard zoom window, right? Negative 10 to 10 for x, negative 6 2/3 to positive 6 2/3 for y. What I'm going to do is I'm just going to set the x from 2 to pi. So 2 to pi, and click OK. And now it gives me 2 to pi, and actually, this is actually a pretty good window. Sometimes it's going to be way off the screen. So what I'm going to do now is I'm going to go to Menu, Zoom, and I'm going to do Zoom Fit. Now, Zoom Fit is something that when we had the old TI-83s, people used all the time, but they didn't understand how to use it. You have to set those X's correct first. After you have the X's set, now you can do Zoom Fit. And what it does is it does a really nice job of fitting the Y values perfectly to the X values that you've picked. So whatever X values you've picked, it'll make sure you have a really nice window for the Y. And now it's really easy to find my 1, 2, 3, 4. It looks like there's 5 zeros. So now I'm going to go to Menu, Analyze Graph. I'm going to do zeros. Scroll through that first one. There's our first 0. I'm going to grab and move that. Go to Menu, Analyze Graph. Going to do a 0. Scroll through. There's our second one. Do this a couple more times. Analyze Graph. 0. Scroll through. 2 more. Menu, Analyze Graph. 0. Scroll through. And one last one here. Menu, Analyze Graph. Should have made my interval smaller. Goodness. All right, there we go. We have our 5 zeros between 2 and pi. Now, next thing we're asked to do is to make a sign analysis on this interval. So what I'm going to do, I found a stylus. So let's go to big there. And they ask us to do a sign analysis on this. So let's see here if I can get a pen. There we go. So I'm going to make my number line. A little bit longer maybe. And I'm going to mark off all those zeros. So let's see what we got. We got 2.24, 2.53. So here's 2.24. Here is 2.53. What else do we have? We have 2.75. And we have 2.93. And our last one is 3.09. So what sign analysis means, we did this back when we were doing rational expressions, is the function positive or negative between these? Well, if I have a graph, right, because on the solve function, we already had these values, right? There they are. Okay, these are exactly the same values I got from the graph. But once you have them, you have no idea if the function is positive or negative in between them. We don't know anything about this function. If you have a graph, you have it right there. Look, before this first 0, positive. Boom. Done. After or between the next 2 zeros, we're negative. Looks like we switch every time. Positive, negative, positive, negative. So we're going to positive, negative, positive, and then we're negative. Okay, and you have that sign analysis done for that interval. So graphing, really big advantage, because in calculus we talk all the time about whether functions are increasing, decreasing, positive, negative. Really important that we're able to get those positive and negative intervals between those zeros. So definitely recommend graphing anytime that it's an option. For solving a function, graphing, definitely the way to go. And all you really need to do is practice. A lot of students initially say, oh, that takes so long. Why can't I just use the solve function? Because you can't see these changes from positive to negative. That is so important. Okay? So just a little bit about how to use Zoom Fit. So we set that X interval, and then we did Zoom Fit, Menu, Zoom Fit, which was letter A. So you just type letter A if you wanted to right down here. And that's going to fit it automatically to the X window that we have. Really nice anytime you're given an interval like this. Cool. We'll keep those. And let's move on. So, graphing to solve an equation. We have 2 methods to do this. So we're going to solve x squared minus x equals 4x minus 6 by graphing, and we're going to confirm analytically. That really just means we're going to use algebra to prove that this is going to work. So what I'm going to do is I'm going to graph both sides of this function. So I'm going to graph x squared minus x. So let's get rid of this guy. So I'm going to graph x squared minus x. And when I hit enter, I see nothing because I'm on a weird window. So I'm going to go back to Zoom Standard. There we go. Now we can see our parabola. And I'm also going to graph 4x minus 6. So I'm going to do tab. I'm going to graph 4x minus 6. Okay, so we're looking for intersection points. So it looks like something happens here, but I can't really see what's going on. So I might move it a little bit. I still can't really see, so I might use Zoom Box. So menu, Zoom. I'm going to do Zoom Box. There we go. And let's just kind of do from here to here. There we go. Now we can see those nice intersection points pretty easily. So I'm going to go Menu, Analyze Graph, Intersection. And, oh, sorry, we should talk about why I'm doing an intersection. I want an intersection because there's an x value that makes both of these sides the same. When we're at that x value, that's the solution to the equation. So let's find this intersection on the right here. So I'm going to sweep through. Intersection right at 3, 6, and let's find this other one as well. Move ourselves a little bit. So I'm going to go Menu, Analyze Graph, Intersection, and sweep through that point. There we go, and that point's at 2, 2. So now, some people ask, well, do we want the x or the y? Well, there's a couple hints. One is that the function has, the equation has x in it, so x is probably the coordinate that I want. And also the y coordinate, basically what that is, so like this 3, 6, when I plug 3 in, on the left side I get 9 minus 3, which is 6. On the right side I get 12 minus 6, which is also 6. So that's the value of both sides, but I'm asked to solve for x. So in this case, I definitely want that x coordinate, which is 2 and 3. So now let's confirm it analytically. So I'll go big here so I can use my stylus. And we'll use maybe like purple this time. So what we're going to have here, we got x squared minus x equals 4x minus 6. I'm going to move everything over to the left side. So we're going to have x squared minus now 5x plus 6 is equal to 0. So that looks like it's factorable. So x and x. So I'm writing so big. Stylus is a little bit different than what I'm used to. So we're going to have need a positive 6 and a negative 5. So 6 I can get from 2 and 3 or 1 and 6. Both of those actually make a 5. But because we have a negative middle term and a positive last term, we need them both to be negative. So it's going to be negative 2 and negative 3 equals 0. Yeah, it looks like x equals 2 and x equals 3 are our solutions, which is exactly what we got from the graph. Very cool. All right, let's look at the next one. We're going to solve 4 sine of 2x on the interval from 16 to 22. Interesting. Well, let's graph both sides. So I'm going to graph 4 sine 2x. Get rid of this guy and this guy because we don't need those anymore. So we're going to do 4 sine of 2x. Hit enter and go to zoom standard again. You could play with zoom trig if you want to. Zoom trig basically gives you a nice negative 2 pi to 2 pi. And now I'm going to graph 3. So I'm going to go menu, tab, and graph a 3. Now notice 3 cuts across a lot of times. Once again, if you were to use solve on this, sorry, I'm going to go to my current document and just go over to that. So if you use solve on, was it 4 sine 2x equals 3 comma x, it's going to give you a bunch of n things. I do not want that. We could use the bar with where we want it, but I think that's clunky, and we can just graph it faster. So we've got the red line. We see it intersects an infinite number of times. What was our interval? 16 to 22. So I'm going to use, this sounds like a great candidate for zoom fit. So I'm going to go to menu, I'm going to go to window, set my settings from 16 to 22. Not going to worry about the Y for now. In fact, the Y right now is at a pretty good spot, but I can go menu, zoom, zoom fit to make sure that it's going to give me a nice picture. And that actually moved it in a little bit so I can see it a little bit better. Looks like I'm looking for 1, 2, 3, 4 intersection points. So I'm going to scroll over just a little bit, and I'm going to go to menu, analyze graph, intersection, cross through on the left. Looks like 16.132. And do that again. Analyze graph, intersection. I'm not going to do all 4 of these because you guys can do the rest of them, but it looks like we have 4 intersection points on that interval, and we can see that the graph, it's below to above to below to above to below. So, benefit of graphing, you get that picture, you can really see what's going on. Remember those y values, obviously it's going to be 3, because we're trying to make it equal to 3, so both sides will have to be 3, but the x coordinates are what we're looking for on that interval. Cool. So, that's method 1 for solving an equation by graphing. Now method 2, this one is maybe a little bit easier for kind of understanding the change in the sign of the functions. What I can do on this problem is at any stage of an equation, you can actually graph it to find a solution. So like for this guy right here, let's go back to a full screen. What I can do is I can say, okay, I want to solve this. Let's solve it kind of one step at a time. Let's add the 4x. So we got x squared minus 5x is equal to negative 6. Well, we just said you can solve any equation by graphing both sides. Let's graph both sides of that. So we're going to graph x squared minus 5x. Let's do that. Get rid of these. Oop. Okay, so I'm going to graph x squared minus 5x. And I'm not going to see anything, so I'm going to go back to Zoom Standard, menu 4, 5. Okay, now we can see that. And I'm also going to graph, what was it, -6. So I'm going to do tab, -6. So those two spots that it intersects should still be the same solution. So I'm going to go Menu, Analyze Graph, Intersection. There's 2. And there is 3. So different equations, but same solutions, because I just moved a piece over. Still the same thing though. Now if I add that 6, think about what that'll do. That'll move the parabola up 6. It's going to make the 0 line cut through exactly where I want. So if I add 6 to both sides here, let's do that. So plus 6, we have x squared minus 5x plus 6, which is really how we solved it before, equal to 0. Now what I can do, the benefit of this is intersection point, I'm going to be looking for zeros. So I'm going to go back to my equation. I'm just going to add 6 to that. So that moves it up 6. I'll get rid of our other one because we don't need that anymore. And now if I just find those zeros, I might zoom box that so I can get a little bit better picture of it. There we go. And now if I find those zeros, whoops, I'm not going to do that. Escape will get me out of a mode always. Okay, there we go. So I'm going to go to Menu. This time when I analyze, I can do a 0. Should give me 2. There it is. And 3. Oops, not what I want. There we go. Okay, so we get those 2 spots. So doing it this way, you always are looking for zeros, which is kind of nice. And like I said, you see that sign change, positive, negative, positive. Cool. So the other one, you can imagine we're just going to subtract 3, right? So I'm going to do, let's zoom it standard. 5. So I'm going to go tab, go up, get rid of this. So I'm just going to graph 4 sine of 2x minus 3. And now I'm looking for zeros. So if I kind of scroll over to where we wanted between 16, where are we? There's 15, 16, so right about there. So our 1, 2, 3, 4 zeros. And if you want to find those, I'll let you do that. You could do zoom fit to be able to get in on there on the right interval, but you're looking for the zeros. And notice we've just moved it down. So instead of that 3 line crossing it, now the 0 line crosses it. Kind of a neat way to solve a couple equations. All right, so last thing we're going to round out with here, parametric and polar graphing. And really for these, I just picked some fun equations, and we're going to talk a little bit about how you can trace them and see what the points are at different spots. So on the AP test, there's always one of these two for sure, and sometimes both. And so I just wanted to show you how you can do this on your calculator because it's pretty easy, and show you how you can trace. So we're given this parametric equation. X is t squared plus 1, y is t minus 1, and t is going to go from -4 to 4. So let's see if we can graph this. I'm actually going to add a new graph for this. So I just hit on, I'm going to go to new graph. And what I'm going to do is I'm going to go to Menu, and I'm going to go to Graph Entry Edit, number 3, and I'm going to choose Parametric, because I'm graphing a parametric function. Now I just type in my equations. So x looks like t squared plus 1. Got to use t because it says x of t. So I'm going to do t squared plus 1. And y is going to be t minus 1. And notice they have t going right now from 0 to 2 pi. I want t to go from -4 to 4. Now I will say I haven't played around with this quite as much, so I don't really know how the zoom things work with this. You can play around with them if you want to, but everything else works the same. I can drag, and I can see where we're at. Now they want me to find the x and y coordinates at 3 different t spots. Now I obviously could just plug these in to get x and y, but because we have the calculator, let's give it a shot. So I'm going to go to Menu, Trace. Trace will let you follow the curve. I'm going to do Graph Trace. Now what happens is when you hit the left arrow, it's going to go backwards in terms of t. So notice we start here at t equals -4. And then as we hit to the right, t is going to increase. So it becomes less negative. And the whole time it gives us the x and y coordinates of every single point. Kind of cool. And if you want a specific point, like we're asked for, I think it looks like -3, I can just type in -3, hit enter. And it's going to give me the coordinates of x and y when t is -3. Do the same thing with 0, gives me 1, -1, and same thing with 2.5, gives me 7.25, 1.5. just a neat little way to be able to trace a polar curve, or no, sorry, a parametric curve. And you can see as t increases how the curve is created. Not too bad. This next one is pretty cool. Try to graph it along with me. So it looks like 6 cosine t plus 4 cosine 1.5 t. So we got, let's go, just change these. So we got 6 cosine t. That was it, plus 4 cosine 1.5 t. And the y, oh, I like it, there we go. The y is 6 sine t. Oh, come on. Minus 4 sine 1.5 t. First time I saw this, I thought it was a pretty cool little graph. Let's see what it gives us. So I'm going to have to zoom out a little bit. Let's, oh, and I forgot to change my t. So the t, in this case, needs to go from 0 to 4 pi. And pi right next to the h. There we go. Hit enter, and that gives me the whole thing. Look at that, makes a star. So I'm going to zoom out. Let's do a zoom out here from the center. And maybe I'll do a zoom box to be able to get a real nice picture of that star. From here to here, maybe. There we go. Okay, so we have this nice star. And once again, we can trace to find those points. I'm not going to go through that. But this is actually, it has to do with a cycloid. If you have a circle within a circle and you trace a point as the circle rolls inside the other circle, it ends up creating this star shape, which I think is pretty cool. So, a little bit of parametrics. Now let's take a look at a polar graph. So we're asked to graph the polar functions and to trace the graph. Notice when the graph is at 0 and what the period is. So let's go here. I'm going to add a new graph. I'm going to go to Menu. I'm going to go to Graph Entry Edit. I'm going to choose Polar. Okay, so now we have r of theta. Mine is given an f of theta, but it's the same thing. So we have sine of 4 theta. Theta is with the pi. It's right over here on the right. And hit enter. Very small, so I'm going to go to zoom box. I'm going to make a box around it. There we go. Hopefully get a nice picture. There we are. Now we're asked to trace it. Move that function out of the way. So I'm just going to go to Menu, Trace, Graph Trace. Now, some of this, if you hit left and right, you can go around. So we have our 0 radians. Some of this is really just understanding how the curve is formed. So I'm going to hit my right arrow, and I'm going to watch how it's made. So make that first petal, and then we actually go negative. Notice R is negative at this point because the angle is actually still in the first quadrant. All right, we're still in the first quadrant with the angle, but we need a negative R. It's going to bring us down over here. And now when we go into the second quadrant, we have positive, and then when we continue on, we go negative. Then in the third quadrant, we'll have positive R's, and then we go negative up here. And then one more positive R, negative R, positive, and then we're back to 0. Okay, so this is either 0 or 2 pi. You can think about it either way. But the important things in calculus is when those petals start and stop, and then the period. So it looked like that one took a whole 2 pi right down here to get around. Let's take a look at a different one. Cosine of 3 theta. So I'm just going to tab, we'll change this guy. Cosine of 3 theta. The reason I chose this one is because a lot of people think that all polar graphs have a period of 2 pi. Watch this one. If I go to Menu, Trace, Graph Trace. So I'm going to go back to 0. At 0, notice you start out on far out for cosine, because if you have a cosine of 0 is 1. So we're actually way out here at 1 to start. And then we're going to go up, down, watch the theta. We're at 1.4, 1.5. And we're done actually at, we come down to here, at 1 pi. So at 1 pi, we are done. And all of the odd sines and cosines have that property. And it's because it just overlaps itself again. Okay? Not too shabby. All right, I think I got one more. 2 plus 3 cosine theta. 2 plus 3 cosine theta. Get rid of that multiplication. All right, so I'm going to have to go to a zoom standard here. So zoom 5, and I'm going to do a zoom box to get a better picture. Right here. There we go. Oh, that kind of squishes it, but that's okay. Some of the zoom you kind of have to play with a little bit before you get it how you like. So we are cosine, so I think we're going to start probably out here, but let's trace it. Yep. And as we increase theta, it's going to come up. And what happens with this is that when cosine becomes negative, which happens on the left side of the graph, is we're going to end up subtracting more than 2. So that's why it ends up going on this negative little loop over here. Now I think we're at pi. So at pi, we're on the negative side, and that's going to finish the loop and come back to 0 at 2 pi. Cool. Not 0, I guess we're at 5, because 2 plus 3 will make 5. So hopefully this is informative. You learned a little bit about graphing on your calculator. Be sure to practice this stuff as it comes up in the course throughout the year. Make sure that you're practicing it and that you're really getting familiar with your machine, because they're really useful and necessary on the AP test. And you're going to learn all kinds of fun calculus stuff to do with them next year as well. Hope you enjoyed the series, and best of luck, and have fun in calculus.